Number 28, a student mixes dilute silver nitrate with excess sodium chloride to form the silver chloride represented in the net ionic equation above. Let's kind of rewrite the equation ourselves, right? Because that's net ionic reading of the spectator ions, but let me write it this way. Ag plus NO3 minus plus Na plus Cl minus goes to that one. We have AgCl, and then we have this sodium nitrate, which is super damn soluble. So this is going to immediately dissociate into Na plus and NO3 minus. Perhaps that's why they probably got rid of this, and that's how they have that net ionic equation, right? Reading of the spectator ions. So which of the diagram below best represents the ions that are present in significant concentration? So this is a super easy question because look at the KSP. I mean, you shouldn't even look at the KSP, to be honest. I mean, if you're literally facing the AP exam very soon, then you should immediately know that solubility, all those like solubility rules, of which silver chloride is like literally one of the most famous insoluble compounds that every AP chemistry student should know of. So this is not soluble. So AKA, don't expect yourself to see any silver ion or a chlorine ion, but in this case we are going to see chlorine ion. I'll show you in a minute why. But you should not expect to see any silver ion, because all that silver ion, if there were any silver ions, it would have probably formed silver chloride, because that thing is super insoluble. It's not going to go reverse and, you know, dissolve back into silver ion. So anything that contains silver ion in the solution should all be wrong, aka answer choice B, that's a big fat no-no. And same thing, answer choice D, big fat no-no. You cannot expect to see that. Now, a lot of people will just immediately go for A because, oh, like Steven, you just said, like silver chloride, well, they're probably going to be forming a solid and it's not going to reverse back, right? So yeah, you're right. But what did the question say? They probably underlined this for a goddamn good reason, right? Excess sodium chloride. So you have a lot more of the sodium chloride. So yes, fine, all these chlorines will pair up with a silver, but take a look. This is your limiting reactant, and this is your excess, right? So let's just hypothetically say, I don't know, like you had 100 of this and you had like 1,000 of this, right? So I'm going to, at the end of the day, the sodium chloride is going to dissolve into sodium plus and chlorine minus, of which I'm going to get 1,000 of each because I had 1,000 to begin with. Now, of these guys, out of the 1,000, well, the 100 is going to react with the silver and form silver chloride, right? And the rest of the 900, where do these guys go? Somewhere. Well, it's probably going to be floating around in the solution. So I better see some chlorine ion in the solution, which is why answer choice C is correct, that I should see some chlorine, whereas if you look at A, there's absolutely no chlorine. And that's not true because I will see some chlorines. The chlorines that we had in excess that had no more silver ions to pair up to become silver chloride. So this was a very simple stoichiometry question that is kind of combined with the whole solubility rule thing, but you didn't even have to know the solubility rule because they literally gave you the KSP value and is very small, meaning this thing is just not soluble.